Yeah, good morning to all the third year family students. So let's continue our discussion. So this is Dr. Sunil Kumar. So I think we have completed the discussion of uh, general principles of chemotherapy, and in that I have discussed about selection of an antimicrobial agent. So before selecting an antimicrobial agent, what are the points that has to be considered? So that we have discussed. So today I would like to begin with different antimicrobial agents. I would like to start with sulfonamides. Okay, so let me share a screen. Yeah, I think this is quite visible to everyone. Yes, sorry. Yeah. Yes. Yeah, this is sulfonamides. You can see the heading here, sulfonamides. So first of all, sulfonamides were the first antimicrobial agents. They are the first antibiotic or antimicrobial agents. So they are effective against pyogenic bacterial infections. Pyogenic bacteria means pus-producing bacteria. The bacteria which is causing pus. This pus means protein-rich infection. Protein-rich, I mean to say that protein-rich inflammatory product. That is the definition of a pus. Pus is nothing but it is the protein-rich inflammation product or inflammatory product. Means those microorganisms which are responsible for producing pus. So sulfonamides were very effective against pus-producing microorganism or pyogenic. Okay, pyogenic bacterial infection. That is pus-producing bacteria. Okay, and why I am using antimicrobial agent here, you may be surprised why I am not using antibiotic. Let me tell you, sulfonamides are not obtained from any microorganism. So when I call an antibiotic, it should be produced by a microorganism. Am I right? It should be synthesized from a microorganism. But here, sulfonamides are sulfa drugs. Generally, we call sulfa drugs or sulfonamides. They are they are synthetic. They are prepared in the laboratory. Okay, that's why I use the word antimicrobial agent. AMA, antimicrobial agent. Okay, it's generalized term. Okay, and especially as it is a synthetic drug, I can't call it as antibiotic. I generally call it as antimicrobial agent. Okay, so I will repeat, sulfonamides were the first antimicrobial agents which are found to be very effective in pus-producing bacteria, pus-producing or pyogenic bacterial infections. Okay, and here this the story of sulfonamides, the invention of sulfonamides, the history of sulfonamide begins in 1930. In 1930, a scientist by name Domag, D-O-M-A-G, a scientist by name Domag, he introduced or he invented one of the dye that is called sulfonamidochrysaldine, or we call it as prontosil red. I will repeat, in 1930, a scientist by name Domag, he used or invented sulfonamidochrysaldine or prontosil red, and after inventing this drug, he used the drug in the treatment of streptococcal infection in mice. Okay, and he found that it is highly effective. It is found, and he found that the drug is highly effective in streptococcal infection in mice. The reason why he tested on streptococcal infection by using this prontosil red or sulfonamidochrysaldine is his daughter is suffering from a dangerous and dreadful disease that is nothing but streptococcal septicemia. Okay, so the daughter of Domac, she is suffering from streptococcal septicemia. Septicemia means that's toxins, blood poisoning, poisoning of the blood. So streptococcal bacteria will release certain toxins in the blood, and that will result in blood poisoning. And he used that sulfonamide of chrysidine or prontosil red in the treatment of streptococcal septicemia to his daughter, and he found that it is very effective, and he subsequently cured his daughter. He cured his daughter with prantosil red, who is suffering from streptococcal septicemia. Okay, by using prantosil, he cured his daughter uh, who is suffering from streptococcal septicemia. Okay, but this led to further inventions. Okay, so it was confirmed that streptococcal septicemia was cured by prantosil red very effectively. Okay, and later in 1937, it becomes very clear that prantosil red, which is very effective, which was used by Domag in the treatment of streptococcal septicemia to his daughter, and he cured his daughter suffering from streptococcal septicemia by prantosil red. It was discovered that in 1937, prantosil red was not the actual drug which is going to be effective on streptococcus bacteria. Okay, that is first producing bacteria. Prantosil red is broken down into a compound that is called sulfanilamide. Please pay attention. Sulfanilamide is the drug which is effective on streptococcal bacteria. Okay, prantosil is a prodrug which is broken down into sulfanilamide, and that sulfanilamide is very, very effective in the treatment of streptococcal septicemia. Okay, and the antibacterial activity which we have seen is not due to prantosil red. It is due to the conversion of prantosil red into an active molecule that is called sulfanilamide. Okay, then what happened? A large number of sulfonamides or sulfa drugs which we are using, they are produced by using sulfanilamide. Sulfanilamide is used as a standard drug, and large number of derivatives of sulfonilamides, which we call it as sulfonamides, have been used, extensively used nowadays, have been produced and used extensively in subsequent years. Okay, but the problem is due to the rapid emergence of resistance. One of the problem is resistance. Due to the rapid emergence of resistance is one of the problem. And another problem is we have more effective and safer antibiotics than sulfonamides. Please try to understand why sulfonamides utility is limited. Why we can't see sulfonamide everywhere? Because earlier they were used for many infections, but now the problem is resistance. Many microorganisms have gained resistance towards sulfonamides. And another point is there are many drugs which are very effective and safer than sulfonamides. That's why the current utility of sulfonamides is limited. Okay, their current utility is limited because of resistance, and another one is safer drugs are available and effective drugs are available than sulfonamides. Okay, yeah. Let me discuss the chemistry, a small, I mean to say that, a brief discussion. So as I told you, all sulfonamides are the derivatives of sulfanilamide. Here you can see sulfanilamide. Okay, and sulfanilamide is nothing but para-amino benzene sulfonamide. It is para-amino benzene sulfonamide. This is the structure of sulfanilamide. I think it is quite visible to everyone. So this is at para position you have NH2 group, and here this is sulfonamido moiety, SO2 NH2. Okay, and here individual members will be different in nature. Okay, so if you do substitutions at both sulfonamido position and even here at para position, so the drugs, the nature of the drug will change. For example, here N1, so this here N1 substitution, that is sulfonamido nitrogen. This is called sulfonamido nitrogen. If you substitute if you add functional groups, if you attach functional groups here at N1 position, that will determine solubility, potency, and pharmacokinetic property. Okay, so attachments or substitution at N1 position will change solubility, will change potency, and will also alter pharmacokinetic property. Okay, the same thing if substitution occurs at N1 position, at sorry N4 position. Okay, para amino position. Okay, for here amino group, what you can find here at para position. Okay, that nitrogen of this para position amino group, if you do substitution here, that will alter antibacterial activity. That will alter antibacterial activity. That will down antibacterial activity. Okay. Yeah. Yeah. Thank you. I will stop now. We will have a discussion in the next coming class. Okay. You watch this video and let me know if you have any doubts. Thank you.